Welcome to my YouTube channel. So in the previous lecture of complex analysis, I have discussed the complex numbers and some properties, and also I have solved some important problems, and today I will discuss section 1.2, that is geometric interpretation of complex number. So a complex number z equal to x plus iy, that is also can be written as x comma y, may be thought as a vector or directed line segment in the complex plane and can be pictured as an arrow from origin to the point x comma y in complex plane. So this is x-axis, y-axis, this is origin, and any point x comma y, that is also complex number xi represented by x comma y, and we can represent this complex number as a vector or line segment and pictured as an arrow. So we can geometrically interpret a vector in this manner. Also any point like 1 plus I, so you can write it geometrically like this. So this can be written as x equal to 1, y equal to 1. So 1, 1. So from x-axis, x and y-axis. So this is 1 and this is 1. So this will be written as a vector. That's it. And now we will make relation in polar and Cartesian coordinate. So any vector z equal to x plus iy, this is x comma iy, can be written as a vector. So if r is the length of the vector z, that is x plus iy, and theta, this is called theta. Theta is the angle measured from positive x-axis to this vector z equal to x comma y, this vector in anti-clockwise direction. So theta is measured from positive x-axis and it is anti-clockwise, and this is, if this is r, then the relation in Cartesian and polar coordinate, we can write x equal to r cos theta and y equal to r sin theta. So this is equal to, this equation will entitled as 1, and from this we can write r equal to root over x square plus y square, that is the length, that is obviously mod z. We get it in the previous lecture. And also tan theta, from this picture we can find tan theta. This is the perpendicular, this is y, and this is the base x. So tan theta equal to perpendicular y divided by x. So if we name it as equation 2, then we get 1 and 2. So this is the relation of a vector in Cartesian and polar coordinate. So here theta is the argument of this function z. So how we define this theta? The value of theta for which equations 1 and 2 holds is called an argument of z, and we denoted it as theta equal to argument z. So from this figure we can conclude that for z the argument can be in infinite number. Two different argument of z can be differ by a integer multiple, that is integral multiple of 2 pi. So that is 1 can be related as a theta 2 plus minus 2 pi into k, that is k belongs to integer, that is z. So that's why we say that these two different argument of z can be differ by a integral multiple of this 2 pi. For unique value of argument of z, there is a concept called principal value of argument z, and it can be denoted as, this principal value of argument z denoted as capital argument z, and the relation between this, that is arg z equal to capital arg z plus 2k pi, where k belongs to capital Z, that is integral multiple this. So we will find argument for some vector for some complex numbers. So you can note as z equal to x plus iy, and depending on x, value of x and y, the argument z be different, and we follow this rule, that is tan inverse y by x if x greater than 0, pi plus tan inverse y by x if x less than 0 and y greater or equal to 0, and this will be negative plus tan inverse y by x if x less than 0 and y also less than 0, and this will be pi by 2 if x equal to 0, y greater than 0, and this will be minus pi by 2 if x equal to 0 but y less than 0. So this is the formula, and we'll find, for example, let us take 1 plus I. So this will be here in first coordinate, so it will be clearly 45 degree, that is pi by 4, and we can find from this formula. So for this value x equal to 1, y equal to 1, so both are positive, so we follow this rule and we find argument 1 plus I equal to tan inverse 1 y by x, that is 1, that is tan inverse 1, and this becomes pi by 4. So that's it. So this formula can be written as also in the xy plane. So this is x, this is y. So both, when both are positive, so we contain here, and this is minus positive, that is x negative, y positive, and in this region x positive, y negative. In this section both are negative. So when both are positive, the first case will happen, that is our argument will be tan inverse y by x, and when in this region it will be pi plus, so pi plus tan inverse y by x, and when in this region this will be minus pi plus tan inverse, and when in this region we get tan inverse y by x. So these are relation. Let us take another example, z equal to minus 1 minus I, so x equal to minus 1, y equal to minus 1, so argument minus 1 minus I equal to both negative, so here this become minus 5 plus tan inverse y by x, so minus 4 plus tan inverse 1, that is minus 5, tan inverse 1 means pi by 4, so this become minus 3 pi by 4. So that's it. If you like it, please subscribe my channel and I will discuss more. So for today, that's it. Thank you very much.